All right, so let's go ahead and solve some linear inequalities. And when we do this, it's very similar to just solving equations. So if we look at this first equation or inequality over here on the left, you'll notice where it says 6x plus 2 plus 6x is less than 14. What we're going to do is we're going to try to find the x value that makes this statement over here less than 14. Okay, so we're going to find all the x values that make that less than 14. So how we do that is we're going to start just by doing basic algebra. We're going to start to see if there's anything we can collect. Well, it looks like we can collect some like terms in here. It says 6x and 6x. We have 6x's and other 6x's. That's going to give us a total of 12x's. And then we've got plus 2 off to the side, and that is going to be less than 14. Now from here, we're just going to go ahead and do regular algebra. So I'm going to get rid of that positive 2. I'm going to get rid of the addition and subtraction first. I'm going to use the inverse, so which is -2. Bring that to the other side. Draw my line. I'm going to combine them. And when we do that, you'll notice, well, 12x has nothing under it. So I'm going to write 12x. 2 minus 2, they're going to cancel, making 0 because they're inverses. Bring down the inequality just as it is. And then do 14 minus 2, which is 12. Now at this point, we're going to get rid of that 12 that is attached to the x on that side. We want to get rid of every number that is attached to x. So I'm going to, it is attached by multiplication. So we are going to divide by 12 on both sides. And we do that, 12 divided by 12 will be 1. They're inverses of each other. So x is less than 12 divided by 12, which is also 1. Notice the inequality stays the same because we're not multiplying by a positive or negative, by a negative value. Now we are going to have to graph these solutions. So here's our inequality. And now what we're going to do is we're going to go ahead and graph this out. And it's nice and simple. We don't have to do anything too complicated. I'm going to start with 0, and then I'm going to label the numbers 1, 2, and I might label a couple more numbers, -1, -2. And what do we notice right here? It is, we're going to start at 1. Okay, so at 1, I'm going to put a big circle, and I have to determine if I'm going to fill that circle in or not. There's no equals, so it is not equal to. So because it's not equal to, it is an open circle. So I'm going to say open circle. Okay, and then what we're going to do is we're going to also read it. Let's go ahead and read it the other way. It says less than. So we want all the x's that are less than 1. Less than 1. Well, what's less than 1? Okay, 0 is less than 1. -1 is less than 1. -2 is less than 1. And it just keeps going. So when we shade this solution set, we can just keep going. So we can write it as an inequality, x less than 1. We can also go ahead and just graph it on our number line. Now, let's say we were going to do this in DeSmos. Okay, and we wanted to see that it was less than 1 and prove it algebraically. Well, we can type in the original equation, and then we can go ahead and say it's got to be less than, right? It's going to be less than 14. And check out what happens. There it is. It shades. And so you can actually see the graphical piece of it is that, well, if I go here and I click on the intersection with the x-axis, it tells you that it's at 1, okay? The dashed line tells you that it is an open circle, okay? And notice the shading. I'm just going to shade in that direction. Let me do that in a different color so it's easier to see. And it just, we're shading all the way down here. So that would be the same way of doing this with DeSmos and a little bit piece of technology. All right, I hope that helps you out with solving linear inequalities, how to do it graphically and on the number line.